Okay, kiddos, now we are moving on in Unit 8 to proving triangles similar. Okay, so last time we talked about what similar means, right? We said similar means same shape, different size, right? Same shape, different size. That's what similar means. So today we are going to be proving that. Okay, so we're going to talk about 3 theorems that can prove that triangles are similar. So we're not going to judge just by looking at them. We're going to be able to use these as a reason to say that they are for sure similar. Okay, so the first one is going to be angle, angle. So this is going to be our first one. This is going to be our second one. Okay, and this is going to be our third one. So I want to see where our eyes are going to concentrate. Okay, so the first one is going to be angle, angle. Okay, so we do this situation when the information given are angles. So if we see over here, these are angles. And what do we notice? This angle right over here is congruent with that angle. Right, so that one are the same. So how about I just highlight those in green? Right, and then these two are congruent as well. Right? So we talked about this last time. I preloaded. If 2 pairs of angles are congruent, then the third pair should also be congruent. So if these two are congruent, then we know this has to be. Okay? So if we know that 2 are, then we know that 3 are, so that's enough to prove that they are congruent. So we would say triangle ABC is similar to triangle, and let's go in the same order. A is with the 1, so we'd say D. Then the one with the 2 is E, B and E, right? And then the last one should be F. Okay, so if we have angle, angle, if we know that 2 angles are the same, then that's enough to prove that they are similar. All right, so let's go. Next, this one is if the information they give us are the sides. So for this to be congruent with this, all 3 sides must be not the same, but proportional. Okay, so must be. So say we had, we're going to have like the small, say that's the medium and large. Small, medium, and large. For them to be proportional, we have to say the small over the small is going to be equal to the same proportion as the medium over medium, in the same proportion as the large over large. So that's what we're going to ask ourselves, are those questions. Are they? Okay, so all 3 sides must be proportional. Okay, so that's the second one, and that's if we're given the sides. All right, so next, this is if we're given a side, the angle in between, and the side on the other one. So we call it side, angle, side. So if we look at it like this, the angle must be inclusive of, which means included in, the sides. So what we have to see is, say, for instance, this was the medium and that's the large one, and that was the small, right? If that's the medium and large, we know that this angle right here is congruent, right? Because we see that those are both the same. So that would be the angle in between. So for this to be similar, M over M has to be the same proportion as L over L. Okay, so for them to be similar, I have to have the combination of the angle, the sides have to be proportional, right? So the sides that are inclusive of the angle, if that makes sense. So the angle has to be in between. Okay, it has to be in between. The angle can't be one of these, right? It has to be in between that. All right, so those are our 3 things that we're going to be able to use today to prove. Either we're having 2 angles that are the same. If 2 angles are the same, we know the third one has to be, so those have to be similar. That's enough to prove it. If the three sides are all proportional, small, small, medium, medium, large, large, if it is, then we can prove that they're similar. And then if we know a side, an angle in between, and another side, angle in between, if the sides including the angle are proportional, then they have to be similar. All right, so keeping that in mind, let's get right into some practice. Okay, so here's what our first problem is going to look like. Okay, so it's saying determine if this triangle and this triangle are similar or not. Okay, so we're trying to find out, are they similar? Okay, so what do we know? We see this is a side, right? This is an angle, and this is a side. So this is a side, an angle, and a side. So let's put that there. Side, right? That's an angle, and that's a side. Side, angle, side. Okay, and you don't have to keep on doing this, but I'm just saying doing this for now while we're first getting used to this, okay? So we're asking ourselves, the first step, we're asking ourselves, can this be side, angle, side? Well, for it to be side, angle, side, right, let's look over here. Remember we said this has to be proportional to this, and this has to be proportional to that, right? So how we do that is we compare those, right? And we want to see if those are similar. So let's take a look over here, and let's see what we have going on. Let's first check out the angle in between. That's 38 and that's 38. So that has to be true first for it to be SAS. If that's not true, then that's there's no way. So that part is good so far, right? The angle part is good. Okay, that gets a check mark. So now let's compare those sides. So which one's the smaller one? Okay, so 25 is the small. Well, actually, let's look at it this way. On the left side of the angle, right? The left side of the angle is 25. So let's see if we can compare, right? That's what we're going to see if that's the same. So 25 is over here. And then what would make sense over here? 31, right? So 31 would make sense over there on the right side. Okay, so as long as there's different ways we can do this, but as long as we stay consistent, then we'll be fine. So I think this makes sense. The angle in between, right? And then the other side. So then, for this triangle, what would go over here? What would correspond with the 25? Is it 155 or 125? Okay, well, if we look at it, if the 38's over here, 125 goes to 38, then there. So this one corresponds with 25. So that would be 125, right? And then that means the other one has to be 155. Okay, so as we talked about before, I think that's the hardest part, is to set it up like that, right? And I think that makes sense, right? And so there's other ways, and if you do it the correct way, you'll get the same answer. So now, what we do, step number 2, is we're going to cross multiply. Just like we've been doing before, right? So we would say like this times this. And if I did that, for instance, 125 times 31, let's go and put that in our calculator. If I said 125 times 31, that's going to give me 3875. Okay, now I'm asking myself, is that equal? So I'm going to put an equal sign here. Is that equal to this times this, right? So if I put that in my calculator, 155 times 25, that's going to give me 3875 as well. Okay, so the answer is yes, because they are similar because SAS. Okay, so that's what we have to do. If we have the side, an included angle, and the side, we're going to compare those. Right, so what I did is I said side over side compared to side over side, right? That was my question. All right, next, let's look over here. All right, so it says determine if these are similar or not. Okay, so let's look at the first one. Let's see what we have. Are these sides or angles? These are angles, right? So we're asking ourselves, is it angle, angle? All right, that's a question. Well, let's look what we have. This is 45. This one's 45, right? So that one checks out. This one's 104. That one's 104, right? So, excuse me, what can we say? We would say that yes, they are similar because angle, angle, right? Once we know that two angles are congruent, then we know the third has to be congruent as well. All right, so that's just using our knowledge. It's easy. All right, let's keep it going. Let's see over here. Let's see if these are or are not similar. So let's look at the information they give us. Are these sides or angles? These are all sides, right? So we're asking ourselves, is it side, side, side? Right? That's what we're asking. So for it to be side, 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 we have to ask, is this small over small equal to medium over medium, which is equal to large over large? Okay? That's our question. All right, so let's go ahead and do that. All right, so let's think about that. Let's go ahead and label these first, right? So if I said that this one's my small one, that would be my medium one, and that would be my large one, right? And then what about over here? I would say that one's my small one, right? That one's my medium, and that one's my large one. So I'm going to compare to see if these are all equal. So let's look at that first one. So if we did that, small over small would be equal to 9, right, over 45. Okay, so if I put that into my calculator, alpha y equals enter, that's going to give me 1 over 5. All right, so now let me do medium over medium. If I did that, medium over medium, I'm going to get 12, right, over 60, 12 over 60. Okay, if I put that into my decimals or calculator, that'll also be 1 over 1/5. So that, so far, so good. All right, now let's check large over large. Okay, if I did large over large, the largest one is 14 over 70, right? 14 over 70. Okay, what do you think? Is that the same? We put that in our calculator, that's going to give us 1/5. Okay, so the triangles are similar because SSS, they are all proportional. And they have to all be proportional for it to be side, side, side. All right, so next, let's take a look at another example. Final example, okay? So I think you're doing well so far. All right, so this is if they are similar or not. So let's look at the information we have. Okay, we have angle, angle, side, side. Okay, here we have a side, an angle, and a side, right? Side, angle, and side. Here's a side, 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 and an angle. Okay, so can we do angle, angle? I have angle, angle here, but I only have one angle here. So, not possible. All right, what about side, side, side? Okay, I got side, 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 and I have side, side. I don't have that third side. Okay, so we're going to ask then, can it be angle, side, angle, side? Can it be side, angle, side? Well, let's take a look. What do we know? The side, angle, side, side, angle, side. This angle is the same, right? That angle is 47. So far, so good, right? Now we need to see, so the first step is the angle, and that checks out. The second step is we need to see if the side over the side is equal to, say, small over small is equal to medium over medium, right? And we're going to look over here, right? So which one's the smaller one? Okay, this one's the smaller one. So let's try to set that up, okay? So if I put 16 on the left side over here, what would go over here? That's right, 17. Okay. Then if it goes from the side to that angle in between, then there. So side, angle in between. So it'd be 32 and 36, right? 32 would go over here, and 36 would go over here. Okay. So now that we set it up, third step is going to cross multiply. Okay. So if we do that, I'm just going to switch the color here. Okay. If I do that, 17 times 32 is going to be equal to 544. Okay, and then 16 times 36 that's going to be equal to 576. Okay, well, what do we know? Those two numbers are not equal. Okay, so the answer is no, because of they're not equal. Okay, if they're not equal, that means not proportional, right? And so they have to be proportional to be similar. Okay, that's what similar means, right? Proportional, same size, different shape. So these look very similar, but they're just a little bit off. All right, so make sure you do that practice first in your Delta Math on this before we move on to our next page. All right, kiddos, now let's go ahead and after you've done that practice, let's go ahead and do our last part. So this is quite simple now that we can put that stuff together. It says show that these two triangles are similar, right? So we're going to say which one of these can we use? All right, so let's look at the information that we have. Well, first off, let's think of these as two separate triangles, right? So that's one triangle, and then we can think of like the blue one is the larger one, right? So we can think of it like one of them's like this, right? And we can say that's E, A, C, right? And then there's a smaller version like this, right? And that's going to be still C, but that one's going to be D, right? And this one's going to be B, right? Hopefully that makes sense. Okay, so here's what we know. We know that this angle is the same on both, right? That has to be the same on both. Because, how do we know that? Because these are parallel. Right? If these two lines are parallel, what we talked about earlier in the year is that these have to be the same. So because of that information, right, we know that that angle are the same. All right, well, what else do we know? We know this angle right here is also the same, right? Because it's the same that one, and then that's what's the same, right? So we can say this one and this one. So that is A. Those are two angles. Right? Okay, so that's how we can tell. All right, let's keep it moving. Let's see, what do we know about this one? All right, well, we see that tells us that those two lines are parallel, right? So if those two lines are parallel, we can kind of imagine, right, like if this transversal line in between it cut it, right? If you remember, parallel lines cut by a transversal, that's going to tell us that this angle is the same as that angle, right? Okay, and then if these two lines are parallel, right? And this cuts by this, then this means that this angle is equal to that angle too, right? So, if that is an angle and an angle, then that's enough to prove that those are similar, right? If two angles are the same in those two triangles, right? Because you can imagine we have a triangle like that and we have a triangle like that, right? That one be PQS and this one be SRQ. Okay? All right, let's keep it moving. Next one. We want to prove that these are similar. Okay, well, what do we notice? These are parallel lines right here, right? That's what tells us over there. What else do we notice? Okay, we know that this and that have to be equal, right? Because those are vertical angles that we've been practicing. Okay, well, what else do we know? Well, if those are parallel lines, right? Because so we can imagine like that's cut by a transversal, then we know that that angle has to be equal with that angle right there, right? And then we also know that this angle has to be equal to that angle right over there, right? Because we can imagine that this parallel line cut by a transversal, right? So if these are parallel lines cut by this transversal, that means that angle and that angle have to be the same, right? So then if this angle, let me put this one with 3. Right, that makes sense, right? If this angle are congruent, and then this one, and this one, and this one, then this one's proven by angle as well. All right, so that's our basics on that. So let's go ahead and kind of get into it right over here. All right, so on this one, this is called a bow tie. Okay, so when we see this type of bow tie, here's what we know. The pieces, the parts opposite the vertex are proportional. Okay, the ones opposite those are proportional. Okay, so what that means is this is a vertex that they share, right? So that means these two angles have to be the same. So what that means is the parts that are cut by that, so this to this, is proportional to this to this. So let's look over here. US to TS. It says fill in the other information. Okay, it says enter segments provided that would result in a true equation. Okay, so what would be true about this? US over TS. So compared US to TS. Okay, so this one to this one, right? Well, let's look. Look, if this angle goes in between, here's how we know. This one is going to correspond with this one right over here. And so this one corresponds with the one opposite the vertex. Corresponds with opposite the vertex. So what's opposite the vertex for this one? Opposite US would be RS. Right? What its opposite, that would be RS. So then let's look over here. TS. TS is here. It corresponds with what's opposite the vertex. So what's opposite the vertex from TS is SQ. Okay? So, of course, we could say that's QS or that's SR also. Right? But that's how we do it. It corresponds with what's opposite the vertex. Right? So this one corresponds with that one right over there as well. All right, so when you see a bow tie, that's what we do. Okay, next, this variety. When you see something like this is called a side splitter. So on a side splitter, here's what we want to know. We're asking, is the part over the whole proportional with the other part over the whole? Okay, so that's what we're going to be asking. Is a part over the whole proportional over the part of the whole? So if it is, then it would be a true equation, right? So they want us to fill this in. That would be that. So let's look over here. QO and NO. QO is here. NO is here, right? So QO, this would be the part, right? NO is the whole. Right? So what would correspond, if this is one side, what would correspond on this other side? This is called the side splitter part of it. Side splitter. Okay, so the sides that it splits, right? So if this is the part on QO, what do you think would go over here for this one? Well, if this is the first part, then that would be OP, right? I think that makes perfect sense. Okay, then if this is the whole thing is NO for here, what would be the whole thing for this one? What would be MO, right? That makes sense. MO would be the whole thing. All right, so it's as simple as that. Okay, next, our last one. Enter the segments that would make a true equation. So OP over OQ. OP over OQ. Okay, well, what do we notice? We know that these two are the same, and these two are the same. So they are similar. So let's set it up. What do we know about OP? OP goes from the 1 to the 2, right? So would it be ML or LM? Well, if it goes OP, then it needs to be LM, right? That makes sense. LM. Okay? So then, this one is OQ. O to the not 2, right? O to the not 2. So the first to the not 2. So this would be L to the not M, which would be LN, right? L to the not M, which would be N, LN. Okay, so that's how we think about it. We want to look at those clues that are on there. So that's the basics of our practice today in our notes. If you have any questions, just let me know. I know you got this.